Thank you for joining us for the webinar series by IIT Alumni Center, Bangalore. So as we all know that the center provides a unique networking platform for both the academia and industries, and also it bridges through the projects of national importance. So today we have an interesting webinar by two professors and who have translated their lab research to successful startups. So the first speaker is Professor Prabhu Rajagopal, who is a faculty in mechanical engineering at IITMadras, and also he's an advisor of Innovation and Entrepreneur Center there, and his interests are in sensors design and robotics. He's also recipient of a lot of awards. Some of these are Institution of Engineers in India, National Design Award, and National Swarn Jayanti Fellowship by Government of India. So he graduated from IIT Madras doing his BTech and dual degree MTech, and then he did his PhD from Imperial College London. And currently at IIT Madras, Dr. Prabhu is doing non-destructive evaluation and structural health monitoring research, and which is co-leading the center and also co-leading the Center for NDE. So in this whole process, he has 30 funded projects, 200 research articles, and 20 patents, and quite successful. And also his work spans the spectrum of sensing and data management, leveraging the latest innovation in analytics and distributed ledgers. And the second speaker is Professor Krishnan Balasubramanian. He is currently the institute professor at the IIT Madras and serves as the head of the Center for Non-Destructive Evaluation, which he founded in 2001. He also directs the Gopal Krishna Deshpande Center for Innovation and Entrepreneurship, which focuses on lab-to-market space in India that has influenced 1,200 entrepreneurs and 300 faculty leads. And he has over 490 technical publications, 44 patents, and he has graduated a lot of master's and PhD students. He has received numerous awards in the whole process, and he is fellow of INEA and NASI. So both the talks will be moderated by Dr. Sunil TS, who actually started his career after finishing his PhD from IIT Bombay, and he started his career with the GE Global Research as a mechanical engineer, and later he led a team in providing innovative manufacturing and inspection solutions for GE aircraft engines. So he is now Assistant Vice President with the Tata Sons Private Limited. This is a group innovation, and he has 24 years of experience with the team. So today's talk will be co-hosted by Dr. Sushila Venkatraman and myself. And for audience, post your questions in Q&A box, and that will be taken up during the discussion. So over to Professor Prabhu.
Thank you so much, Dr. Abha, for your kind introduction. So shall I get started then now?
Yeah, you can.
Just sharing my screen now. Are you able to see my screen?
Yes, we can.
Yeah. So good evening to all the audience who have gathered today to listen to me and Professor Krishnan. So our talk is sort of like a continuation with me giving the part 1, whereas Professor Krishnan will speak on the part 2. And we are giving different viewpoints of the same process, which is how do we take some interesting research ideas and make them into products and that can make industrial and social impact. So I'm going to focus particularly on some of our work on robotics, whereas Professor Krishnan will speak about waveguide ultrasonics. Now, all of this is from the perspective of our own efforts at the Center for Non-Destructive Evaluation, which I co-lead together with Professor Krishnan. I also wear the other hat where I am now the faculty advisor for innovation and entrepreneurship at IITMadras. And in this role, um, my focus is to spur more such initiatives and activities, both from faculty members as well as students. So all of this is driven by our research, of course. Fundamentally, my own research is in remote inspection. So when you look at complex structures, particularly that are at, let's say, in very challenging conditions, high temperatures, deep underwater, with under high pressure or inside pipelines and so on. So the goal is to find some techniques by which we can characterize these materials and structures. Although I was trained in guided ultrasonics, that's what I am a PhD in. In fact, I did my master's project with Professor Krishnan at IITMadras, working again on guided ultrasonics. Over the years, I've also looked at robotics as a way of taking these sensors to remote locations. So let's say you have a structure that is 200 meters from the surface. So how do we inspect those kinds of regions? And waveguides may not work. Ultrasonics may not be carried out at such distances. So that's where robotics comes in. So for me, robotics is a handmaiden to do the kinds of characterization that we do using the sensors we develop. So at our group, we have been very passionate about technology transfer and technology translation. So even when I joined IITMadras, I was looking back because somebody asked me for my application pack just last week, and I had written a research statement, and I had written that one of the goals is to spin out companies and so on. Indeed, worldwide in the NDE area, many academics tend to spin out companies. That's because we keep generating newer inspection technologies which may or may not be existing in the industry. And so the only way to actually take these products to the field is to start up on our own as such. So that was how I started my first company, Planys, way back in 2015, together with my own master student at that time, Tanuj Junjunwala. So, and there was another team that was being mentored by Professor Krishnan, and these two teams came together to create this company. I'll describe this journey as we go forward, but Planys develops submersible robotic solutions for inspection of marine assets such as dams, river crossings of road and railway bridges, and more recently, storage tanks in the context of oil and gas. So the company has now done inspections of more than 50 water tanks in one of the major oil and gas refineries. And soon enough, they will also start inspecting oil and gas storage tanks. The other company that has been a lot in the news is Solinas. Solinas develops robotic inspection solutions for pipelines. That was how it has started. But around COVID, the company pivoted to water and sanitation. And so the company develops robotic solutions for maintenance of water and sewer pipelines, as well as more recently, a robotic solution for eliminating manual scavenging in the inspection of tanks. I'll spend some amount of time on this startup as we go forward. And so Solinas was the winner of the Economic Times Startup Award last year. And they were also on Shark Tank India earlier this year. XYMA is a startup that Professor Krishnan will speak about more on, but it stems from our work on developing waveguide ultrasonic sensors as such. Today, despite us being an academic group, we have a footprint across the world, and this slide sort of captures this very surprising scale of our operations. At any given point of time today, there are some teams from our group that are operating in, of course, all of India, Middle East, Europe, East Asia, and also the US. We are able to do this primarily because of our interest in startups and technology translation. And I'm going to unpack a little bit of this journey as we go forward. Because our work is in some solutions which are impacting the society and industry, the general audience in popular media is as well very interested in what we do. So, for example, we are in the news very often for our work developing the septic tank homogenizer, a blockchain-backed solution for maintaining medical records, the robot for inspection of pipelines or inspection of bridges and so on. So this is in addition to our work, publishing in scholarly journals. I personally am very passionate about science communication from my training at Imperial, which had a special school for science communication. And I believe that we need to always communicate what we do to the society at large. So before I go to my specific journey, I want to outline our famed innovation ecosystem, which has enabled all of this. Indeed, IIT Madras Incubation Cell was set up in 2013, and the first startup from our group was created in 2014. So you can see our journey is roughly parallel to the growth of our incubation ecosystem. Now, I'll discuss a little bit of this. So today, we have a range of support that spans the whole of innovation spectrum. When I say innovation spectrum, what I mean is actually literally the TRL spectrum. At the lower range of TRLs, which is what we do as academics typically, is proof of concept. And at the higher upper end, we have products that are deployed on the field. So we have support systems that are spanning this entire spectrum today. So at the heart of it, to me, especially as the faculty in charge of this place, is the Center for Innovation. The Center for Innovation today is about 15 years old. It is the country's oldest such academic body dedicated to innovation. It's actually a student-led maker space. And this building here is IIT Madras's newest building. I would say the coolest and the most happening building as well, which is entirely built with alumni contributions, was just inaugurated earlier this year by Vice President of India. That's how seriously the country takes innovation, and IIT Madras too takes innovation. So with this maker space as the foundation, we've been able to build up from there. So there are a range of support organizations, of course, the venerable IC&SR, which sort of helps, it's a grants office, as well as provides support for project management, HR, legal, and IP, and so on. Professor Krishnan was one of the visionary deans of the same organization few years ago. And we have a range of feeder organizations as well. GDC, for example, again, Professor Krishnan will speak about it, helps to catalyze laboratory research to become products. And then we have the pre-incubator, Nirman. So that organization is also now within this building. I will speak about Nirman also later, but briefly, it is an initiative to support pre-venture ideas. So today, our ecosystem is so variegated that we need support at the pre-venture as well as the post-venture stages. Once we get to the venture stage, we have a number of incubators. So the mother incubator is the IIT Madras Incubation Cell, together with a number of sector-specific incubators, such as those in cyber, physical, rural, medical, and biomedical spaces as such. So this is an example of a set of startups that have come out of this CFI Nirman complex. As such, I've spoken about Planys and Solinas. Agnikul is a very exciting startup. Just yesterday at the TiCon in Chennai, it was declared the startup of the year. They develop micro-satellite launchers. They have their own bay in Sriharikota. Ather Electric was India's first electric bike company. The Modulus Housing can build a 2,000-bed hospital in a week. And at the bottom, we have NeoMotion, which is a socially relevant startup which develops motorized wheelchairs among their marquee products. So you can see the breadth and range of the companies that are coming up, and it's essentially about riding that technology spectrum, readiness level spectrum, as I said. Now, with that, I'm going to give a couple of the examples as we go forward. So laboratory research typically happens at lower TRL levels. So, for example, Abha mentioned this Swarna Jayanti Fellowship. That fellowship supported my work on developing some solutions for studying sound at the quantum scale. So these are, what we call blue sky research, typically where university research sits in, but the industrially relevant solutions are at the higher TRLs. And what happens typically is academic research sort of falls in this, what we call as the valley of death. So that is, we have a lot of research interest in the initial stages when the research is still blue sky. There is a lot of potential for publications, IP filings, and so on. But as the technology matures, the funding dries up. At the same time, the industry is also not very interested in this domain. And this is where technologies typically die. And this is the reason why I or Professor Krishnan started looking at startups very seriously. So, so here is the journey of one of our startups, Planys. On the top right, you see a robot that we called Mike. Mike is named after my PhD supervisor, Mike Love at Imperial College London. And that was created. This is actually the third prototype, still in laboratory. So the first prototype was created by Tanuj, who is now the CEO of Planys, as is finally a master's project. After that, we created another version when he stayed back after his graduation for several months. And after that, we recruited a number of PhD students and master students. Those the research by those students led to many IPs, a lot of publications that have now garnered very wide interest. Particularly, we went into studying propulsion systems, underwater propulsion systems. One of our most acclaimed papers is on studying bio-inspired propulsion, for example. So, you can see the robot on the top right is still a laboratory prototype. Although we had taken it to the field, we started doing trials with it. We used to encounter a number of challenges on the field. So when we create a laboratory prototype, for example, sometimes we are not worried about issues like endurance. We are not worried about, how many hours is this machine going to run before it will encounter a snag. But the very first time we took this machine and tried to make use of it in the Chennai port, for example, one of the cables failed. And the team, although they did not inform me then, had worked through the night, cut the cable meter by meter, isolated the particular segment, and then rewired it back before the machine was ready for operation. The next morning, they showed it to the superintendent over there. So those are the kinds of challenges that we must overcome. So I would say the first lesson on the journey to productization is definitely standardization. So as far as, as long as we are in the laboratory, we are creating something that will run for a few hours, we can live in the glory of the great innovation that we have made. But when it comes to taking it to the field, it is vitally important to make sure of the reliability, of the robustness, of the ability of the technology to face real and practical conditions. Those practical conditions here, for example, could be that there are, the water is very murky and there is very little visibility. There could be chocolate wrappers in the water because of which the rotary propellers will not work. And that's the reason why we started studying bio-inspired propulsion, for example. And it is these kinds of things that help us ride that TRL spectrum. And at the higher TRL levels, the development cycle is really about taking and making the product work in more and more realistic field conditions. At the bottom left, you can see the fleet of robots that are with Planys today. After about 6 to 7 years, even the painting of the robot is industry grade. Yellow is anywhere in the world you would see is the color used for underwater robots. The form factor has stabilized. All the components today are sourced from vendors who have been certified by us for their quality and for their reliability. We obtain these data only then we qualify them. Of course, those products that we are making on our own, or those components, also we test them extensively. Planys has facilities, a hyperbaric chamber, own pool for testing, and so on. So this work has led to a lot of development of knowledge base. I remember that when we started this work, we had almost no funding in robotics. I myself started with training in ultrasonics, for example. One of our alumni, Mr. V. Shankar, cut the first check and said, go ahead, make use of this. But his only condition was that we must plug back in by producing more PhDs, more MS students, and so on. So all that has been fulfilled. Today, we have had graduated several PhDs, about 30 master's projects, and so on. And Planys is also a company that has started delivering worldwide. As I said, the company has a wholly owned subsidiary in Netherlands, for example. Now, with that, I'll step back again a little bit. I mentioned about robustness and reliability. Now, how do we actually, is there a method to this madness? Can we learn from how we take products to the field? I'm gleaning all of this understanding into a set of innovation sutras that I've been publishing. 6 of them are published in India, have been published in India today. If anyone is interested, you can look them up. But at our lab, I believe that we have sort of brought together these elements. One is that there is a atmosphere of the joy of discovery. That is, all our MS students and PhD students are really working for the joy of it. We have not pushed them that, hey, your work should lead to this startup, or, you should get so many publications. That's never the motivation. The motivation is to go and have fun doing experiments, running simulations, and so on. But at the same time, this theoretical work that happens in our lab is very well grounded in practice, because today we have gotten to a point where every one of our projects has a startup connection. Always, there is a interface with one of our startups, and that helps the theory to be grounded in practice. Most of our projects today are cutting across disciplines. That is what I mean by intersectionality here. And impact is something that can be as small as winning recognition in a conference to as large as saving a life. So it is always a feedback loop. I'm going to take up on that particular sutra later. And I also want to say that there really are no boundaries. All of our work is cutting across disciplines. So Professor Krishnan, for example, has worked with physicists. I work with material scientists, electrical engineers, ocean engineers, and so on. And it is this that has given us the edge to take our solutions to the field. Now, coming to that point on impact, so often we find that we start with a lot of inspiration, but we are not able to sustain it as we go forward. So, but what we believe in our lab, and we believe why we have been very successful in belting out startups, is because we always celebrate even the little joys, actually. And the little joy can be, as in this particular project that has later now become a product in Solinas, is winning finally a master's project. So Divanshu, who was the dual degree student working under my guidance at that point, developed the first version of this robot, which we now call the Homo Sep. It was nowhere close to the product that it is today, but it helped us gather attention, draw in eyeballs. So a lot of people got interested. We were working on this problem of manual scavenging for several years until this point, but it was this product that really got the attention from everyone. So that was late 2018, early 2019. And over summer of 2019 to early 2020, we had managed to get our first set of fundings from CSR sources, including Capgemini and Gale CSR. And through COVID, actually, this is what helped keep us going. This is the next version that is produced. You can see the product is a little bit more slick. It is now mounted on a tractor, so it's more mobile. And by this time, we had already filed 4 IPs as well, and had several publications like before. Now, today, this is how this product stands. A further set of funding, including from L&T Technology Services, an NSE Foundation, and more recently, Wells Fargo, has helped us to really productize the solution. We have I have a next slide here. So yeah, so the homogenizer, the concept remains the same from the beginning, like in Divanshu's first prototype, but we have refined it to make it very compact. It is modular. It can be carried on this little towaway that is connected to a truck. The truck has a pump and then a tank as well. And there is also a display unit with can look at the process when it happens. So the impact is there to see today. Even these numbers are old. Today, the Homo Sep robot is deployed at more than 30 locations across the country, about half of them actively using the solution. And very importantly, we've been able to create what we call Safai enterprises, or enterprises led by those who are impacted by this profession. So although we started off as, my interest in robotics was purely for inspection purposes, sometimes there is a spin out or spin-off effect from where we start based on societal and industrial demands as such. So, with that, I would like to sort of come to conclusion. So I have discussed two particular projects from our lab. I've discussed the innovation ecosystem at IIT Madras, and I have gleaned out a set of what I call as innovation sutras and exemplified them with the help of these two startups. How it is important to have a fun research culture, bridge it with practical inputs, work across disciplines, and propel ourselves forward with little joys, little victories on the way, and how they can lead to larger and larger impacts as we go forward. So today, similar principles are being used across a number of different technology verticals. So for example, the same thing can be spoken about our waveguide sensors, which Professor Krishnan will speak about later. Although we are a mechanical engineering, we are in mechanical engineering department, we work across disciplines. And some of our work actually is such that when I presented some of this at a conference last month, somebody said, "Oh, I've never had a better exposition of computer science." So because a lot of our work relates to distributed ledgers, dashboards, simulators, edge analytics, and more recently, quantum computing, for example, to power the data that is being generated out of our devices. So we're talking about Internet of underwater things, Internet of concrete things, Internet of composite things. And the most recent startup from our lab, which I've not spoken about, called Planys, is trying to develop Internet of medical things, all powered by similar dashboards as such. Now, this is where, these are some of the exciting technologies which we believe will take similar trajectories in future. So my fundamental research has focused a lot on what we call metamaterials or engineered materials. The Swarna Jayanti Fellowship I got is also for this type of work. And one spin-off of this work is trying to have seismic isolators, protecting sensitive equipment and installation in seismic zones. Going forward, we are looking at passive sensing of structures without any sensors at all by measuring noise. And we're looking at sound sensors at the quantum scale. With that, I'll stop here just by saying that our work has strategic, social, and industrial dimensions. We started with industrial, but then we started with strategic. Actually, our group was originally funded by the nuclear establishment, but over the years we've been able to make very strong contributions to the industrial sector, and more recently look at dual use cases in the social sector as well. With that, I'll stop here and I'll be very happy to take some questions.
Sunil.
Yeah, good afternoon. Good afternoon, everyone. Thank you, Professor Prabhu. I think you sort of gave everyone an overview of amalgamation of research or academics and the industry. And I think when we look at the flow of your slides and the content, we very well know that you are not limiting to only academics, although you spoke a lot of students graduating, but eventually leading it to an industry-ready product. And you also highlighted, the technology readiness level of these products. And I think that's quite an achievement, I would say. But before the questions start coming, I just had a couple of queries of my own. So when we look at, I think there is a question already, so I would prefer asking that question first. I think Professor Krishnan sort of has given a lead into the whole thing. Role of research center like CNDE provides to startups emanating from labs. So this is in line with what I was also going to also talk to you about. I think Prabhu, we should probably look at sort of giving. I'm sure a lot of students are out there as participants. You might want to also touch upon the technology a little bit. I'm not saying you should actually delve into it a lot. You can just start off by saying what is the sort of technology and what kind of a qualification, apart from qualification criteria into IITs, would lead students to such a lab, which is considered most coveted and also illustrious in my view. I've been associated with you guys since 2006 onwards, and of course before that when I was in GE. So would like to understand, one, how do you actually look at students interested in this research and getting into this technology? Second, what is the underlying technology that you have when it comes to these underwater, apart from should be water ingress proof, should be dust proof, etc. But what is the underlying technology, NDE, so to say? And then we should also look at how students transform themselves into entrepreneurs. Three questions.
Thank you. I think those are very thought-provoking questions, and I'll take Professor Krishnan's question after that, maybe. So, or maybe I'll start with that. Right? I think he's a better position to answer these questions than even I am. But let me just take a shot at it. So, we talk about deep tech entrepreneurship in this country and all over the world today. It's become a big buzzword, which is these kinds of technologies: AI, robotics, blockchain, cybersecurity, cryptography. And so on. These are all areas where some amount of deep research is involved. It is not enough to have a delta X innovation here. To be able to make a disruptive innovation here, it requires many years of painstaking and very disciplined hard work. Like, for example, I've said so many IPs are behind some of our startups. So many publications disclose some of the trademarks, some of the essential elements that go into these products. And to enable that is what is the role of a research center like CNDE. By God's grace, we've been very well funded. So we are able to support these kinds of industrial innovations and help to catalyze product creation. And very often academic research can stop at TRL3, that is proof of concept. But just like in cricket, sometimes you require a sheet anchor, somebody who stays there so that somebody else can go and hit those sixes so that your run rate is high. And I feel the role of a research center like CNDE is just that. We provide that stable pole position with which innovators can go and express themselves. The role of CNDE is not, in addition, is also to provide mentorship, early market access. So we have very strong connections across the industry. And some of our first customers in many of these startups, if you see, have come from those connections, whether it is Reliance for Planys or some of those NGO partners I mentioned for Solinas. They're all connections associated with our lab earlier. So I think those are the twin roles. One is in terms of providing the stability, a sheet anchor position, and another is bringing those networks and connections. Now, coming to your question, Dr. Sunil, so essentially, and this is something I've learned from Professor Krishnan, is that we feel what is best for the student is best for everybody, right? So students come with many different types of aspirations. Some want to pursue further studies. Some want to join the industry. But there are those few who come and say, I want to make a difference, and I want to be a job provider and not a job seeker. So we enable all sorts of students. Just this last week, I've been writing dozen reference letters for students who want to go pursue their further studies in the US. But every now and then, you have these students who walk into our offices. A Tanuj Junjunwala who said, I am bored of industry, or Divanshu Kumar who said, I want to make a difference socially. And that's what that's how we pick these entrepreneurs. So really, it's coming from them. We are not doing anything special other than providing an example or a role model. Why these students are coming to us and not to anybody else in expressing this interest is because we have done these things in the past. So they know that these are the kinds of academics who are working in translational research, and so they are coming to us. Now, what is the core or special technology that goes behind these products? In robotics particularly, it is essentially these microelectronics, things like the Arduino, the Intel Atom. The core of it is that processor, right? So the NUC processor and so on. So today we are riding what we call as the wave of open electronics. I am not somebody who's trained in robotics, but I've been able to venture into robotics because of the revolution sparked by technologies such as Raspberry Pi. They've gone and published their entire source base code for us. The entire architecture is available to us. Today, we can build grounds up very easily because there are communities where you can learn Python scripting and so on. So the software as well as the hardware tools are now open source, and that's what is helping us power these solutions. So at the heart is this. Then of course there are sensors. So the digital data acquisition boards, how these sensors connect with those boards. So these are the kinds of technologies that are at the heart of all this. What are the skills here? The skills are coding languages such as Python, Hadoop. These are the kinds of things that are at the back end of it. JavaScript, React, and so on. Right. What was the third question that you had asked, Dr. Sunil? Sorry, you are on mute.
Yeah, so that's the transformation of a student into an entrepreneur.
So that's a brilliant question, and I don't know whether we are doing it consciously or or it is the end result. We see this transformation in many students. They come in as dreamy young people who really have no specific skill sets other than a burning desire inside them to make a difference. But over a period of time, a combination of things, taking on responsibility. When you take a leadership position, you're responsible for so many people, right? Being out there in the public eye, media, making presentations to everybody, including investors, customers, and so on, and being out there in the field, these are the hammer blows that transform young people into entrepreneurs. There is no bigger catalyst for transformation than 30th of every month, no money in the bank, how do I pay salaries? That is the classic case where many of these, we talk about startups and the glitz and the glamour, but at the back end, there is a lot of suffering, there's a lot of hard work that goes on here. And this is what is transforming these young people. I'm sure, if I would go back and look at myself at that age, I wouldn't have made the cut as an entrepreneur. But today, thankfully, we have these support systems. We have organizations like our laboratory. We have the incubation cell. We have a lot of support, whether angel VC networks or startup funds such as the oil and gas startup funds that are able to catalyze these. But despite these, the real challenges, as I said, try to go sell to a customer who doesn't want the technology, or try to pay salaries to employees when there is very little money in the bank. So I think these are the difficulties that make people grow up. Yeah.
Okay. All right. I think, there would be many which the students might want to ask, and there are a few in my mind as well. But in the interest of time, we will move on to the next presenter. And I think together, towards the end, we will have some time to, delve into some of those questions, which could be common to both of you. Sure. So thank you very much, Professor Prabhu. I think it was quite enlightening to see how you bridge the gap between academics and research, and also making it industry ready. I'm sure that is the tone that you have set, and would definitely ease a launching pad for Professor Krishnan to begin his talk, and then we will come back to you if there are more questions, and definitely for the common set of questions that we may have for both of you. Thank you once again.
Thank you so much, Dr. Sunil. Yeah, pleasure always. Yeah.
Thank you. Yeah, Professor Krishnan, over to you.
Yes. Good evening. Thank you, Sunil. Thank you, Abba. Thank you, Sushila, for hosting us and putting this program together. It's been a pleasure listening to Prabhu. And every time I listen to Prabhu, I learn one extra sutra. So, but honestly speaking, our journey is never planned. A lot of it happens. And it happens because we facilitate within ourselves, among ourselves, and within the lab to actually explore and make mistakes. In fact, my one thing to everybody is, please let me know when you have failed as much as when you have succeeded. And this is a very difficult message that you have to convey to students, because students believe that whenever they meet a professor, they only have to show them the good news. But what is important is that every bad news actually is a bigger learning experience and more than a good news. With that, I will just share my slide and get started. And Prabhu has actually set the stage for me to go one step further and talk about one technology that both Prabhu and I have been working on for over maybe 35 years or so, and what that has led to in terms of how we improve industrial safety and sustainability. So with that, I hope is my slide visible, or am I not? My slide is not visible yet.
Not yet. Yeah.
Okay.
Not yet. Okay, give me a minute. I hope the slide is visible now.
Yeah.
Yes, thank you so much. So, as already mentioned, we are from the Center for NDE. So before we get too deep, I'll just introduce Center for NDE in a very brief way. But non-destructive testing is a part of every process in engineering that you can think of. If you think in terms of manufacturing, right from when you receive the raw material to when you actually make the material into a product. And you can go further by saying when the product is in service, you also have a very significant interest in evaluating whether the product is functioning as per your requirement and whether the product will continue to perform without endangering or providing any disruption in what it is meant to perform. So this is an area where we go all the way from what I would call as a cradle to grave. Now, this is not untrue, right? I mean, when a baby is born, the first thing that you do is actually an ultrasound of the baby before it's born. And then the day it's born, you start looking at how the baby is performing. So you have vision, you have ultrasound, and many other technologies that are used throughout your lifetime to ensure that the human anatomy is intact and is capable of performing what it's supposed to perform, not only today, but also tomorrow. So this analogy is very important because many of the technologies that we use is almost similar to what medical diagnostics does. So many cases you may think of us as developing technologies that help image and help make measurements of engineering structures, engineering processes in a much better way. So whether it's X-ray, whether it's visual, whether it is sound, ultrasound, infrared, and the list goes on. Very similar technologies are used by us, except two things. The first thing is that in medical, most of the time, the human body can be put inside a machine. In non-destructive testing and evaluation, often that is not true. In some cases, it is true. In many cases, you have to take the machine to the product itself. And that's a big change. The second very important change, and there are many of them. For instance, materials are changing all the time, while human anatomy does not change dramatically. New problems keep occurring almost every day when you come to engineering, new designs. And the more importantly, the volume of material that is used. I mean, I've just given an example. You take railways and just take one aspect of the railways. This is the rail itself in which the train travels. If you look at it, it is tens of thousands of kilometers and multiple rails going across the country in all kinds of environment and in all kinds of weather conditions. You go to another example, you take, for instance, either a nuclear energy producing power plant, or you take in terms of a thermal power plant. The environment inside has corrosiveness, it has high temperatures, and many of the conditions I would call as hostile. And how do you ensure that that material, that particular pipeline, that particular component is going to hold up for another 3 years, maybe another 5 years? And more importantly, we have to do this with a significant cost constraint, because without that, no industry will apply these technologies to their processes. So while we actually help safety, we help performance, we have to pay attention to cost. So we have to do it at a very affordable level. Okay, sorry. So we use many technologies. So here are some examples of technologies. Already Prabhu mentioned about Planys, which is doing underwater. I will talk a bit about Dhvani, that is doing on the ground, and then Detect, that does above the ground, where we use extensive robotics. We use technologies such as in the IoT, we use technologies such as data analytics, but more importantly, we use physics. And that is allowing us to do things differently. And here's the example of a drone measuring the wall thickness of a storage tank containing some sort of a product, which could be gas, it could be oil, it could be naphtha. And it is replacing a human being who will be climbing up a scaffolding. It takes a lot of cost and time to set up a scaffolding. The safety of the human being is a major concern. And more importantly, the time it requires to do this can be significantly reduced because you're using a drone, and this absolutely is a much better way to do it. So in summary, our center looks at deep research in non-destructive technologies, but with an intent to improve the performance of engineering problems, enhance the safety for both human as well as environment, and also prolong the life of engineered components, so that we are also striving towards improved sustainability. Because if I increase the life of any component, then we save energy, we save materials, we save raw materials, and we also save human involvement. And this leads to improved sustainability. So we are actually addressing several problems using deep research. And my team, as you already met, Prabhu Rajagopal, but I have Kavita from engineering design, Krishnamurthy from physics, Balaji from electrical, Manu from civil, Rama Prabhu from physics, and Tiju from materials. So it's a very interdisciplinary team that we work together to address this problem. Very happy to say that IITMadras has declared us as one of the Center of Excellences under the Institute for Eminence program that Government of India is supporting IITMadras in. It's a great privilege to be one of the Centers of Excellences of IITMadras. In a nutshell, our center actually looks at testing, monitoring, basically looking at non-destructive testing, but also it looks at what if I can put these sensors in the process itself, and also look at how we can use it for long-term health monitoring, which means that can I leave these sensors while the system is operating? So in order to do that, I will look at only one technology, and this technology is called ultrasound. You all know ultrasound from medical side because you use that to image a lot of internals in your body. Ultrasound absolutely means high frequency sound waves. These travel inside materials. Now, the conventional ultrasound that you see in medical field is called as bulk waves, which is longitudinal and transverse wave, which you are all familiar with. However, it is also possible to generate what are called as guided ultrasonic waves. When I say guided ultrasonic waves, we are talking into the waves that have a certain characteristics. One of the most common waves is called a Rayleigh wave or surface wave, which can be definitely looked at from a practical perspective. Now, guided waves are not new to us. Even as a child, we have actually used guided waves to communicate with each other. But guided waves are waves that can be confined in any geometry. It could be plates, rods, cylinders, curved surfaces, anything. And we actually have experienced guided waves in a very profound way back in 2005, when the tsunami actually, which was generated wave in Sumatra somewhere underground, actually influenced us by traveling across the globe and these would be called as something like a surface waves. These actually traveled around the globe a couple of times, although we experienced it only the first time around. So guided waves are not something that you are not familiar with. Now, the question is, how do we harness them? And interestingly, guided waves have different mode shapes, just the way you talk of longitudinal wave and transverse wave. You can also have many other types of wave modes, wherein you look at how the wave is moving through the material versus how the wave is actually, the particles are vibrating as you go across. A very good example of a wave or a guided wave is if you go to a cricket stadium and you have the Mexican wave that travels across, you and I actually travel across the stadium, is where you and I sit and stand. So which is like we are a particle that is moving, but the wave actually is an abstract energy that actually travels around the stadium. So these are, so depending on how you sit and stand, you can create different wave modes, and each wave mode can be applied to measure certain things that other wave mode probably cannot do the same way. So just to keep that in mind, a lot of advantages. I would not go into why we are using this, but essentially it allows you to do things that other the bulk wave modes do not. So my research in this started way back. My PhD, I was one of the first PhDs that happened in guided ultrasonic waves for non-destructive testing when I was at Drexel University way back in 88, 89 timeframe. And we have, I've been working on that primarily from material characterization for composite materials that I used for stealth purposes, either in the aerospace or in the naval structures. I came to India in 2000. We set up the Center for NDE in 2001. And Prabhu has been almost a part of it from the day one. And we worked on guided waves for our aircraft industry, particularly in composite industry, trying to see if we can do a health monitoring where we have sensors built into the composite structure and monitor it over the lifetime. And till 2010, IIT Madras did not have an infrastructure or a policy in place that allowed us to translate research into startups. It was only 2010 when this could be done. So we started looking at how do we take some of these technologies and move them into something that is of use to the industry, and how do we leverage that? As Prabhu mentioned earlier, most of our good work earlier used to land up as reports, as papers, even as patents. But then that didn't really have an impact on the industry. It didn't have the impact on the society. It didn't have an impact towards creating jobs, creating technologies, making India a technological leader. So this didn't happen before. But since 2010, this process is enabled at IIT Madras. And that leads to my next topic, which is called as a technology that we developed is called HOMC, or Higher Order Modes Cluster. Like many discoveries, this was accidentally discovered by my student. And the idea, the problem statement was that pipes are used in plenty. If you don't mind, just go outside your house and see how your pipes are. Whether it's a pipe that's feeding water into your house, or whether it's a pipe that is leading the wastewater out of your house. They are always supported, and these supports are prone to corrosion and very difficult to inspect, because if that pipe is bad, I have a trouble even lifting it up. Now, the question is, how do I measure this corrosion? There was no method. So that's when we actually started working with Bharat Petroleum out of Mumbai. And we started discovering, and accidentally we discovered a zone in these guided waves that actually worked so well that it made me disbelieve that we have actually solved a problem. So it took us about 6 months to understand how this actually technique works. And based on that, we were fortunate again to partner with ExxonMobil out of both Singapore and US. We spent about 5 years validating this technology at different sites across the globe. And what is important to understand is, as at IIT Madras, we don't have the bandwidth to do that. So we took a partnership of a company called Dhvani Research that was formed as one of the early startups at IIT Madras. And by 2013, Exxon had accepted this technology. And by about, this is a little old numbers, but today we have a technology that is used in more than 12 countries. And this video is an example of how this technology is used. So there are two major problems that we address. One problem is the storage tank. The storage tanks, as you can imagine, hold very hazardous and critical products. It could be crude, it could be naphtha, it could be gas, or it could be anything that, if it leaks, becomes a major headache. Now, the problem is that these storage tanks rest on a 8 to 10 millimeter thick metal plates that are welded together. Think of it like a foundation of your house. And it is prone to corrosion from inside as well as from the outside. Now, the biggest problem that you have is that the corrosion is often focused very close to the edge, but on the inside of the tank. One way to evaluate it would be to empty the tank. But then emptying a tank is an extremely expensive, and it may take about 3 to 6 months to empty a tank and to put it back together. So the question that came up was, can I inspect corrosion happening inside from the outside? So we had developed the technology that shows how to do it. It had to be quantitative. And here's an example of a report that we provided much earlier. This was done probably in the 2012-13 timeframe. On the right, you have an animation. On the left, you have the actual robot. And we were able to pick defects and quantitatively provide information that others could not do. And we also noticed that we can use it to monitor the growth of this damage over a period of time. And we were able to also tell the company when to intervene and actually change this plate of water plate, or call it annular plate. And as I mentioned earlier, changing this annular plate is a very expensive proposition for them. And also the tank becomes unavailable. So this is an example of a technology solving an industrial problem. Another example is shown here. This is one of our company's inspectors. He is inspecting the corrosion at that support location. This is not a pipe per se, which is transporting fluid. This is a pipe that is used as a crane member. So this is an offshore rig, and you can imagine the criticality of this particular member. So here again, in those support locations, you have corrosion happening. And in order to ensure that the corrosion is not going to influence or lead to anything that is a safety issue, our technology actually provides a quantitative assessment of that particular corrosion in the skin region. So just to give you an example, these two applications, it took us about 5 to 6 years after the technology has been discovered to make it into a product that can be reliably implemented, can be transferred to a large number of companies across the world. It should provide the reliability. It should provide the cost effectiveness. It should also provide the scale that allows the technology to grow. So today we have several companies that are involved with us. Companies like Baker Hughes, Exxon, Shell, Indian companies like Reliance, Bharat Petroleum, just to name a few. We have more than 1,200 tanks that are under constant monitoring using this technology, and that number is growing. We have something close to 10,000 pipe supports that we have inspected over the last 3 to 4 years. And this technology is a Atmanirbhar technology that is going global. Another technology, again, to some extent, was initiated by a student called Tarun Mishra, who did a dual degree project with me, where we actually looked at how can we monitor these pipes. So you have pipes, and we looked at pipe supports only. But what about the rest of the pipes? You have pipes that can corrode from the inside. You can also have pipes that can corrode from the outside. Particularly, pipes do become vulnerable when these are at higher temperatures, operating at higher temperatures. So the question is the technology for using these guided waves. And in this process, we actually are sending the wave along the length of the pipe. And these technologies were already known to be able to inspect pipelines. But the limitation was that it could only do it at normal temperatures. So the question that was posed to us was, can you do it at higher temperatures? That's when Tarun and I, when we worked on a technology, we discovered that there are magnetic tapes that you can actually make that actually can generate and receive ultrasound using the physics of magnetostriction. And this can be operated at higher temperatures. And Tarun actually showed that we can actually do it at up to 350 degrees continuously for several days to months. That's when Reliance took over. We worked together. Reliance took a leap of faith, gave us some money to do trials, and we put a team together. Today, we have hundreds of these sensors in the field. This technology is called GUMS. And the way it works is, of course, then we start to bring in other technologies such as how do we, implement it in an IoT platform, and how the data is analyzed in the cloud, and how the data can be mined to get more information than just corrosion. Today, the data can give you far more information than just the fact that something is corroding within it. The fact that you can actually predict certain ongoing process changes is another added factor that helps the companies. Today, we have technology certified up to 200 degrees Celsius. As I mentioned to you, technology can work to 300. One of the hard learnings, and this is something that whenever we deal with oil and gas and several other industries, is certification. We need to look at certification very carefully. So for instance, this technology we know can work to 300 degrees Celsius plus, but it's not certified, and certification takes a significant effort, time, and money. So we are actually working towards increasing the temperature to which it's certified. But commercially, this is extremely useful. We have numerous installations across the world, and you get data on your cloud into your computer, and you can actually start to monitor where the corrosions are taking place. Is the corrosion growing? Are there concerns? Are there red flags that you need to work about? Of course, the data analytics provide you with the trend lines and also a lot of insight into what's going on. We are also able to handle certain complicated issues such as bends and other types of geometries where corrosion is more prevalent. A large number of clients here, as you can see, and the company that is taken this technology forward is called Detect Technologies, and it is one of our marquee companies that came out of our center and IITMadras. The third and the last case study I'm going to just mention is one called as PORTS. PORTS stands for Portable Rheology and Temperature Sensing. So we are measuring rheology, which means viscosity and density, as well as temperature altogether. In fact, this work was something that I had been working on for at least 15 to 20 years prior to 2014, which started in the US. And what we were looking for is, how do we implement it in the field? So maybe a lot of the work we did earlier was just not, the industry was not ready for it. But around 2013-14, I started seeing a lot of interest from the industry. We also had to look at it from a more holistic perspective. So the aha moment was when the Waveguide sensor was able to do all the three, density, viscosity, and temperature at the same location using the same sensor at the same time. That became a unique Again, like what Prabhu said, we back it up with a lot of patents. And we started working towards a lot of industries supported our work across the platform. Today, again, it's fully commercialized. And as we speak, we have several installations across the globe on several different problem sets. But interestingly, this is a very good example. So what happens is I send a wave along the, what do we call it, the waveguide. And we look at reflections from those waveguides, and based on the difference in the signature between adjacent waveguides that are reflected from something like a notch that's reflected, sort of like a, what you have in a, echo sounder. So you have, echoes that's coming from the notch, and then you have something coming from the end. And then you take the difference, and that tells you what's going on in and around that particular zone called as the gauge. And if you do that, then I'm just showing you an example. This work that was done way back in 2017 or so, where we demonstrated that using the same sensor, if I heat a particular fluid, which is a viscous fluid, then you're simultaneously measuring temperature in blue and the change in rheology in red. So you can see that as I'm increasing temperature, then I'm holding the temperature now. Now I'm going to again increase the temperature. And as my temperature increases, the fluid becomes less viscous. The density decreases, the viscosity decreases, and we are monitoring it. So the question that comes up is, fantastic, where do you use it? You use it in polymer industry. We are now working towards implementing this in the paint industry, in the polymer industries such as resin systems. We can also show that we can implement this in very, very hostile environment. And that's where our example comes. For instance, what you see on the right-hand side is our sensor being dipped into a molten metal. And we are measuring for the first time in the world the properties of the molten metal as it is being melted. Today, we are seeing this applicable in industries such as aluminum, industries such as nickel, zinc, and very soon we probably will have it working for steel also. And just to let you know that when we did this for the first time, the comment we received from the industry was no sensor has lasted more than a minute or two, while our sensor has been working for days and still working. So this is an example. So our proposition to the oil and gas industry is very high. For instance, we believe that every unit can save anywhere from $2 to $3 million on a single unit per year. You can also look at metal industries, and the actual value proposition becomes incredibly more attractive. So we are on the left, you see a finished product, which is one of our sensors. So we have different types of sensors that actually are used. And this is an example of, again, a technology that has deep roots in the lab, moving to the field and solving more than one problem in a very consistent and reliable way. We are this supported by more than 25-30 patents, more than 25-30 publications. Lots of money has been spent on R&D, and of course we are now able to translate that into a company that has global relevance. Examples of some of the clients are shown here. I will not dwell more into that. And so just to summarize what I've been trying to convey, and Prabhu, both of us have been trying to convey, is that today, whether we do it consciously or more, it's become a systemic nature in our center, idea that is generated is looked at from a translational perspective. It is looked at from a startup perspective. So over the years, from the start of the lab in 2001 to formation of companies like Dhvani in 2010, Planys 2015, almost every year we have a company that's come out of our center. Most gratifying fact about this is the fact that we have today about more than 1,000 tech jobs that have been created, a lot of it in India, but not only in India. More than 95% is in India, but we still employ people across the globe. And this has created a model or a path for many more. As Prabhu was saying, there are a couple of more, maybe more than 2 or 3 more startups that are in the anvil. And we will see them emerge over the next couple of years. This is an example of the global footprint that we have. The big stars represent our academic collaborations. The small dots are our industrial partners and large clients through either directly or more importantly through our startups. And this has created a value proposition that is epitomizing the mantra that our Prime Minister has been talking about. Is make in India, but make for the globe. I think the footprint is growing, and I think we're going to see a few more dots and few more stars in this map, not very far from now. So that I will just conclude by saying that we have an ecosystem that we believe is thriving, and particularly epitomizing the lab to market transition. And we absolutely thank IIT Madras and the ecosystem that's built over the last 15 years. That is the reason why we are able to do things that are disruptive, that are contributing, and most importantly, making India proud and making India as a technology leader and a technology supplier to the globe. Thank you.
Thank you, Professor Krishnan. I think, there is an echo from some system. All right, so I think, thank you very much for, such an enlightening talk. I guess, you answered many questions which probably students or anybody out there on the call or on the webinar was, intending to ask. So, I mean, one question, of course, is, how do you deal with high temperature, molten metal, etc.? And I think he got the answer in the subsequent slide. Professor from NIT Trichy, I guess. So essentially, if I have to kickstart some of the discussions around this, I guess initially when you talked about or you kicked off your session, I guess you mentioned about how to deal with failure. I think that's paramount in my mind in terms of encouraging students to experiment. It's basically Indian culture has been parents asking their kids as to how much did you score, rather how many people did you help. And I think your Center for NDE in what you said actually epitomizes the fact that failure should be encouraged. And I have a sort of a follow-up on that is to how do you actually encourage students in your lab to fail? What is that freedom to fail sort of environment that you have created? If you can elaborate on that, please.
Yeah, absolutely. As I mentioned to you, this is the hardest lesson that we try to give to the students. Okay, as I said, most of them believe that they need to show the good results only. And for me to extract the bad result from them is a huge challenge. So every time they say, sir, this worked, I say, what did you try and what failed? You tell me that first before you tell me what worked first. Okay, that's the first thing. Second, it's very important to encourage them to learn from failures. For instance, I've had severe situations where the student has made a mistake and actually cost me money and time because they made a mistake. Now, I have two options. I can really be unhappy about it. On the contrary, I can also be telling this guy, hey, no, don't worry about it. You actually crashed a computer or you crashed an instrument. So be it. I will face a consequence. But what is important is you tried. Okay, you tried. So we encourage them to try different things. In fact, I keep telling them, prove me wrong. You will graduate the day you argue with me and you show that I am wrong and you are right. And that's the day when I know you are ready to graduate. So this is my mantra, that we want them to try different things. I also tell them that your thought process when you are within the center is extremely different from the day you step out. In the center, this is your best opportunity to try different things, try ideas, generate ideas, learn to fail, no problem. The minute you step out, your mistakes are going to cost you significantly. But within the center, we do not, we encourage them to fail. We do not say that, hey, you made a mistake. We lost some money, or we lost an equipment, or we lost a transducer. So be it.
Excellent, excellent. That actually gives a lot of confidence to students now and students who are going to come in future. I also had a question on, you mentioned that there has been a presence of, CNDE and its spun-off startups across the world. And I saw that also in the global map. So I just also wanted to sort of, add to what you just mentioned about freedom to fail, is that, at Tata's, we actually look at rewarding the innovations that actually were dare to try. The award itself is actually called Dare to Try. So
Yes.
on one edge, on one extreme, we have the academics who is actually having, encouraging the students to fail and giving them the freedom to fail rather. And then in the industry, we actually look at, having the freedom to fail, and we call it as, Dare to Try, which I think substantially increased the experiments, the trials, etc. The students actually, the industry professionals actually were doing, and that actually took us miles ahead. In terms of CNDE and Tata, I know in general industry in India, one thing which actually comes to everybody's mind is the speed before we even talk about accuracy, right? Because as you rightly said, there are challenges across the industry, right? In oil and gas pipelines, the challenges are different. The pipes run hundreds of kilometers, whereas in the industries which are sort of manufacturing locally, again there are challenges of its own. So how do you marry when you talk about these technologies? And you beautifully also summarized how medical imaging or medical NDE, or rather obviously it cannot be non-destructive in medical, but how it actually relates to what we do in industry, right? So at much higher energy, much higher frequency, etc. But nevertheless, you do pull out the defect. So in a sense, we actually look at saving lives in either ways, right? So
Sure.
Structural integrity, medical science, everybody starts looking at saving lives. So in that, alluding to that is the speed, and in most of the cases it is also about early warning, right? While we talk about reactive measures in terms of okay, I put a big pipeline inspection gadget inside a long pipe, and then it travels kilometers, tens of kilometers, and then I pull out and then look at the data. But there is also the speed that we want to get to. So what is your idea, or what your thought process is in terms of attacking the speed and at the same time the accuracy piece?
So there are two things that you mentioned. First of all, as you know, that I was certainly a part of some of the early innovation programs that you guys conducted, called Innoverse and Innovista. And I must say that I've been very impressed with what Tata Innovation Group has been doing. In fact, I must say I shamelessly borrowed one of your phrase. It's called "Be Bold." It's a beautiful, beautiful, beautiful 2 words. Okay, and I have tried to make that as a mantra, not just at our center, but also at IITMadras. If you look at our, some of our early presentations by our leadership, you'll see the "Be Bold" as a major factor that we are, doing. So dare to dream is just a part of that. So we are, and we have to focus on letting our young minds, and that is when they can do things without thinking about the consequences. So we need to encourage that, and we need to do it at all levels, at right from kindergarten all the way up to when they graduate. So this is something that we would want to do. And amazing things happen when that happens. The second aspect that you mentioned here is industry connect. None of what Prabhu or me demonstrated today would be possible if we didn't have a significant leap of faith provided at some juncture or at multiple junctures by companies like Tata Group companies, okay? Whether it's Reliance, whether it's ExxonMobil, whether it's Shell, whether it is some other companies. Companies have come ahead and said, let us take a leap of faith. Let us put some money into the center's activities. Let's see what we get out of it. As we speak this week, we're going to hand over 3 units of an inspection system that will change the way hydrogen crackers are going to be inspected in the future. And these are fully operational, tested over 2 years, field tested, modified. The biggest problem that we have is most of us are very good in developing ideas. We are also very good in developing technologies, but the technology is half completed. In fact, I would say even 20% completed. The 80% is in the validation, the robustness, improving the robustness of that particular technology, and to, more importantly, to get a buy-in from the end client. All these are very difficult things to do. And so, but we have learned how to do that. It is not easy. As Prabhu said, it is not easy at all. I mean, in fact, whether it is, I have to crawl under an aircraft. I guess today I'm a little old to do that, but not long ago, I could actually crawl under an aircraft or climb a storage tank that is 40 meters high and hang, by this little ladder. Okay. We were ready to do that as faculty. All right. So the question is, how do we, so we have to change. We want the industry also to change. So there should be both a push and a pull from both sides. And then miracle can happen in India. The last part you are talking about is how do we sort of handle, or how do we address the problem? That the problem is incredibly large. Okay. We have, as I said, the infrastructure industry is very, very large. Whether it's bridges, dams, rail lines, roads, you take it, pipes, cross-country pipes. The problem is very, very large. So the question is, how do you handle it? The only way we are developing technologies. There are 2 ways by which we are approaching it. One way we approach it is by saying that, can I use robotics? Can I use data analytics to improve the ability to handle large structures? The second way by which we should look at is, can I build these components, components with sensors built in or built on it? Right. Now, for the second one, you saw that we have developed these gums. Okay. Now, same gums, believe it or not, while it is fairly an expensive unit for high temperature, if I convert that into normal long distance pipeline, we can make it affordable. I give one example. All right. So we have a company come to us and says, can you put an IoT platform with ultrasound to monitor the level of a fluid? We also need to know where this particular component is and at what temperature it is in. And I also need to know what is the level of the fluid. If I can get that, then I can actually implement it across the world. And the numbers that they were talking were in tens of thousands on an annual basis. Fantastic. Then we said, yeah, we can do that. Fantastic. We know how to do that. Then they said, how much will it cost? We said, we thought we were really frugal. We went through a lot of calculations and we said, it'll cost us, we can somehow make it. If you give these kind of numbers, we can make it at 50,000 rupees per unit. And the guy started laughing at me. Okay. He said, if it is more than 2,000 to 2,500 rupees, we will not be able to handle it. All right. So the question is, while we have done a lot of cost cutting to get to 50,000, the question is, how do you get from 50,000 to 2,500 rupees per unit? And just now we have another company that's talking the same number. $50 is what they want the entire unit to be. That includes the sensing unit, that includes the battery, that includes the transmission antenna to some remote site, and probably the electronics at the other end. $50 a unit, but then the numbers are hard. So how do we identify problems? How do we cut costs? And if we do that, if we do it affordably, then we can have sensors that are built across the country, and handle these large volume problems by using health monitoring technologies. But the key thing would be the reliability of that, the cost of that, and the implementability of that.
Excellent, excellent. Okay. So I think we have one more question, but I think that is more related to the medical field. Working on AI-enabled endoscopes, I guess that's probably in the medical field. But
yeah, but IIT does work in that area.
Yes.
So, but we don't do that. We could, but I think there's a better place to do that. So if somebody wants to get in touch with me, I'll be happy. I'm typing my email ID on the screen. Okay. It's probably already on the screen, but I'm just typing it on the chat box also. All right. Okay, I think that is, and Prabhu has done the same, but I think these are, if somebody, you can do it on the forum, that'll be better, because I think this is only to the hosts and panelists. So if somebody can convert that into, to the participants, then be nice. Either way, you can easily find me. Just go to the website and type my name, IIT Madras website, which is iitm.ac.in. You will get it. So yeah, you should be get it. But I request the the organizers to convert it, please. Okay, it should be to everyone. Yeah, thank you. Yeah, so we're happy to connect you to the right people.
Right. So I think, that question actually led me to ask you one more question. And I think most of us on the call would be very curious to look at it. What is your take on AI-enabled NDE inspection? And to some extent, you can also touch upon NDE 4.0, which rhymes with, Industry 4.0. So can you just, bridge both of them and also give us a perspective on what is the role of AI in not generative AI for the moment, but at least, AI in the NDE inspection?
So AI is absolutely going to play a very important role in everything that we do, including non-destructive testing, medical imaging. It's already doing to some extent. Today, we have, again, one of our startup has significant products that is available that focuses on the interpretation of data. So this is where you can see whether it's the medical field. For instance, COVID really pushed that envelope in a significant way, where medical imaging, and probably there are about 30, 40 startups across the globe that focus only on X-ray image detection using AI. So very similarly, we have interpretation of ultrasound images, ultrasound data, AI on X-ray data, which allows the industry to reduce the dependency on manpower and expertise, because the expertise is going down, the problems are growing. So it's becoming untenable to use experts for all this. So AI will replace, to some extent, either replace or assist experts in making decisions. Now, I think AI is going to go way beyond that. Okay. AI, the way I see it, maybe 5, 10 years down the road, is actually going to dictate how this needs to be done. All right. And AI, one of the areas that we are focusing on is called as computationally driven AI. What that means is today AI is data driven. Okay, I slightly should change that. It's physics-based computationally driven. Okay, so where we believe that what is done today by using models like finite elements, finite difference, and so forth, numerical models and similar models will be replaced by AI-based models. Okay, interestingly, we have a leadership role in that particular field global today. So we have demonstrated that whether it's infrared imaging, whether it's ultrasound imaging, we can actually develop models that are replacing numerical models, but functioning at orders of magnitude faster and can function on very simple resource like a cell phone or a simple palm top. Okay, so what needs to be done on a workstation today can be done faster, as well as do it in much lower resources. And this technology is something that we have some leadership positions in. There are others also working in that, but our approach is a little different from some of the other approaches. So we have already demonstrated that in 2 domains. We probably will expand that further. So AI is going to be here to stay, and NDE is going to benefit significantly from that.
Yes, yes, yes. I'm sure it will. And I think, the fact that we need certified professionals to interpret the data that is coming out of ultrasound or X-ray or eddy current would actually someday I see AI-assisted inspection where the A scans and the B scans are easily interpreted by AI-assisted inspection. So there is a clarification on the question by Bridge Mohan. He says it is not medical, but he's saying endoscopes are used for manifolds, which I think he's talking about crank case. I think it's probably a typo there. So can you elaborate on that?
Yeah,
I think, yeah, go ahead, Professor Krishnan. I'll answer after.
we can do. We will definitely love to look at it. We do have a vision-based, work going on, which actually does involve either rule-based or AI-based. So we can definitely look at it from that perspective. In fact, I would not be surprised if we have worked on a similar problem for the same company that probably gave supplied the endoscope. All right. So we have worked on the back end for one of the major companies, and which supplies endoscope globally. So we can definitely look at it. All right. But maybe for a different problem set.
Yes,
so,
yes. And I think,
yes,
I think it is the vision-based approach that we can talk about when it comes to endoscopes. But do you see
we have used endoscopes in small pipes. Our group has been one of the few NDE groups in recent years that has worked on this. So we are able to inspect pipes as small as 5-6 centimeters using the push camera or endoscope that we have. This is also called boroscopy. So we have some work done in this area, and as Professor Krishnan will be happy to look at more. Yeah.
Yeah, I think boroscopes have been predominantly used in automobile for inspecting engine cylinder bore as well as
crankcases. And AI is giving a new lease of life to this very old technology. Yeah.
Right. Yeah. So I think there is a question on the resources that are available.
It's open to all. I just answered that.
So
it's open to all. We do have a very clear, and we work with so many industries. We work with probably 1,000+ industries on an annual basis. So and we take projects as small as 1 day, 2 day consulting, all the way to something that can go several years. With regards to anybody who has an idea and they want to incubate, our incubation cell is open to receiving applications. If you want to do pre-incubation, that's something that Prabhu and I can also talk about with anybody who's interested. So we do have, and we are not exclusively only for IIT, teams. We are open to other teams joining us.
Sure. Yeah, I think we are just about time to sort of wrap this up. And I take this opportunity to thank both Professor Prabhu as well as Professor Krishnan. I think it is wonderful to listen to you as always. And I think you sort of brought to the fore the elements of research, bridging the gap between academics and industry, and more so to make business out of it, right? Which is churning out more and more entrepreneurs from an academic institute. Good also that there were elements of technology that you touched upon. I know it's very hard to actually delve into those topics, which are very intense in terms of science and technology. So time is very short, but I think nevertheless, I think the students or whomsoever out there got a gist of how things will turn out to be if they want a career out of this NDE, so to say. Thank you very much once again, and over to Sushila and the IITB Alumni Center.
Thank you very much, Professor Prabhu, Professor Krishnan, and Sunil. Really appreciate your taking the time to be here with all of us. Just a few quick takeaways from today. What we saw was the specific application of one set of technologies. Well, not one, but the primary technology, which was the ultrasonic waveguide technology, with specific application to safety and sustainability. And we saw several examples, several applications of that with HOMC, the inspection of the inside and outside for corrosion. This is a really, really big thing for industry, because they don't need to stop operations or wait for routine maintenance or empty out a structure just to find out what is happening inside and if there is a risk associated with all of that. We looked at GUMPS, which is about monitoring pipes, especially at high temperatures. And we looked at the challenges and how all of that is dealt with. We saw PORTS, which is portable rheology from the outside. And particularly for the process industry and very hostile environments like paint, oil and gas, metals, etc. This has a huge amount of application. Way back several years ago, when I was doing some work with BPCL, pilferage and quality of oil reaching the petrol station was a big issue. And someone climbing up and actually putting a physical dipstick in, as compared to that, something like this would be so immensely helpful for a variety of applications. We then saw what goes, or rather we started by looking at what goes into making all of this happen. What is it that takes deep tech from the lab to industry and through the entrepreneurship process? We saw a few points. We saw the ecosystem set up at IITMadras and how we saw a lot of details around all of those little bits. Encouraging cross-discipline collaborations, industry immersion, connect, and collaboration, the ability to test and up the game in terms of more realistic field conditions, build robustness and reliability into the product, the need for scale, which is what different applications are going to bring in, and that is what is really going to move an organization from adopting a piece of technology, taking it out, to really becoming something impactful. But then we said that more than anything else, the right attitude is important, and the must-do attitude that Professor Krishnan talked about. Finally, he talked about push and pull between industry and academia. That's an area that we at the IIT Alumni Center, Bengaluru, are also working on. That's our mission, really. It was really heartening to understand how all of this has resulted in a set of technologies homegrown within India, within the lab, and how it has been possible to take all that out into the world and impact not just Indian industry, but industry worldwide. This has been very inspirational, and it has certainly been a very insightful evening. So once again, thank you all very much for agreeing to be part of this session today. And to our audience, thank you for your interaction and for your participation. Until the next webinar, good evening and see you. Thank you again.